up. Wind shear, wind shear, wind shear.
The 737 warning systems use inputs from other systems to alert pilots about the condition of the airplane, airplane configuration, traffic near the airplane, and ground proximity. These are the primary components of the warning systems. Different types of alerts are given to the crew. The master caution and fire warning lights are on the glare shield near the system annunciator lights.
Climb, crossing, climb. Climb, crossing, climb.
Pull up.
Computer voices, oral alerts, and visual prompts also warn the crew. The stick shaker is a tactile alert that tells of a near stall condition. It is important for the crew to know these different alert signals.
Descend, descend, descend. Clear of conflict.
The Traffic Alert and Collision Avoidance System, or TCAS, helps to keep safe traffic separation. It gives alerts, flight path guidance, and traffic displays to the flight crew. TCAS is discussed in a different lesson.
Wind shear, wind shear, wind shear. Terrain, terrain, terrain.
GPWS alerts the flight crew to wind shear, terrain, glide slope deviations, and configuration problems. GPWS alerts include these 7 dangerous areas. The alerts are voice messages, visual messages on the attitude indicator, and lights. GPWS is discussed in a different lesson. Fire and overheat alerts are supplied by the fire warning system. Fire warning is also discussed in a different lesson. The 737 uses lights of different color to show system conditions. Red shows conditions that must be corrected immediately. Red lights and words are put in front of the pilots. Amber lights tell of conditions that must be corrected when you have time. Blue lights tell pilots the condition of systems in operation. They show when electrical power is available, the position of valves, and interplane calls to the pilot. Lights are bright blue while valves move, and dim blue when they are in the position set. Green lights tell pilots that the correct landing configuration is set. Speed brakes are armed, leading edge flaps are extended, and the landing gear are down and locked. The master caution system lights are on the glare shield. They illuminate with the system annunciator lights to show the pilot's system conditions where a correction is necessary. An alert in the pilot's forward vision area does not illuminate the master caution lights. If a malfunction is sensed, the master caution light and the related system annunciator lights illuminate. System annunciator lights tell the pilot to look at the system panels for other lights. The flight control, fuel, electrical, APU, anti-ice, hydraulic, doors, and air conditioning annunciator lights refer to the overhead panel. The system annunciator lights are in the same sequence as the overhead panels. The IRS and engine annunciator lights refer to the aft overhead panel. The overhead annunciator light refers to the overhead panel and the aft overhead panel. The overheat detector annunciator light refers to the overheat fire protection panel. The system lights and their related malfunctions are discussed in other lessons. An overwing exit has opened. This made an overhead amber light illuminate. The door's system annunciator light illuminated, and the master caution lights also illuminated. Push one of the master caution lights to reset the master caution system. The master caution and system annunciator system is reset. It is armed to alert the pilots if different problems occur. The pilots should now correct the door problem. Push one of the system annunciator lights to recall all active faults. One push on the system annunciator panel, a procedure named recall, shows the pilots which problems are not corrected. Some systems operate with 2 or more signal channels. Faults on 2 or more channels cause the system annunciator light to illuminate. Faults on only one channel are not shown until the system annunciator panel is pushed for a recall. For this example, the flight control annunciation shows a single-channel fault in the flight control system. The speed trim fail light illuminated when the annunciator panel was pushed for a recall. Push the master caution light to extinguish the lights. Here are the systems with single-channel fault annunciations. An overspeed makes the clacker noise operate. A stall makes the stick shakers operate a vibrator on the yoke. The aileroos supply data to the oral warning module and the overspeed clacker. Decelerate to the correct airspeed to stop the clacker. The test switches, which are used only on the ground, make the aileroos operate the clacker. A red and black bar and an amber bar on the airspeed indicator show the high speed limits. The pilot feels the yoke shake and hears a rattle when he is near a stall. The airspeed indicator has a red and black bar, which indicates the speed at which stick shaker occurs. An amber bar shows the minimum maneuvering speed. The two stall management computers get data from many sources. The stall management computers make the stick shakers move the yokes. Stall warning test switch 1 shakes the captain's control column. Stall warning test switch 2 shakes the first officer's control column. The 737 can tell the pilots of dangerous conditions before the takeoff. These conditions cause the takeoff warning to operate until the conditions are corrected. Thrust levers advanced to near the takeoff position and the stabilizer trim is not in the green band. The trailing edge flaps are not set between 1 and 15, or the leading edge devices are not configured for takeoff. The speed brake lever is not down, or the spoilers are not down with the speed brake lever down. And the parking brake is set. Visual and oral signals tell the pilots when the landing gear are not down and the airplane is near the ground. Red shows that the landing gear do not agree with the landing gear lever. This alert occurs when one forward thrust lever is in idle and altitude is below 800 feet AGL. A green landing gear light shows that the related landing gear is down and locked. When all lights are extinguished, it shows that all the landing gear are up and locked. The landing gear warning horn is heard when the flaps are between 1 and 10, the radio altitude is less than 800 feet, one thrust lever is between 0 degrees and 10 degrees, and all of the landing gear are not down. Stop the warning horn with the landing gear warning horn cutout switch on the control stand. The warning horn is also heard when the flaps are at 25, the radio altitude is less than 800 feet, and one thrust lever is between 0 degrees and 10 degrees, and one is more than 34 degrees. And all of the landing gear are not down. Stop the warning horn with the landing gear warning horn cutout switch on the control stand. When the flaps are at 15, two thrust levers are less than 34 degrees with one less than 20 degrees, and all landing gear are not down. The horn sounds and cannot be stopped. When flaps are more than 15 and all the landing gear are not down, the horn sounds and cannot be stopped. Here is a review.